All right. So now we're going to talk about solving, which, similar to inverse functions, your answers are going to end up being angles. So we have this equation right here, and our goal is to determine what the value of x is. So I'm going to start by writing out my problem. 2 sine x plus 5 equals 4. And I'm going to start by isolating this term right here, the sine of x. So I'm going to subtract 5 and divide by 2. If I subtract 5 and divide by 2, I end up with sine of negative 1/2. Now to get x by itself, you want to take the sine inverse of both sides. When you do that, these cancel out, leaving you with x equals inverse sine of negative 1/2. Now, when we were evaluating inverses, we were just asking what is the inverse sine of negative 1/2. We had to use those restricted domains. In this case, we don't have to worry about a restricted domain. So when we're solving, we want to know all possible values of x. When we're evaluating, we want one specific value of x. So in this case, I'm going to ask myself, what values on the unit circle have negative 1/2 as y? Hopefully you've memorized your unit circle, but if not, we can go down here and I can quickly take a peek at my unit circle, and I can see that 7 pi over 6 and 11 pi over 6 are the ones that have negative 1/2 as their sine value. So I would say that x is 7 pi over 6 or 11 pi over 6. So again, when we are solving, we're back to using just our unit circle values. When we are evaluating, that's when we have to use those restricted inverse sine, cosine bounds that we talked about in section 8.1. Next problem, do me a favor and change that to a -2, and we'll begin. Hopefully you can start without me. 4 cosine of 2x minus 2 equals 0. I'm going to add the 2 and divide by 4. When I do that, you end up with 2 over 4, or 1/2. And then I need to inverse both sides to get 2x equals inverse cosine of 1/2. So again, I'm not worried about that restricted domain anymore. I'm asking myself, what are all of the values where cosine is 1/2? When I look at that, I find that it's pi over 3, and it is 5 pi over 3. However, notice that I have this 2 right here, so I'm actually going to split apart my problem because I'm not quite done. And I'm going to say 2x equals pi over 3, and 2x equals 5 pi over 3, okay? In order to get x by itself, I need to divide by 2, okay? Remember, dividing by 2 is the same as multiplying by 1/2. So x becomes pi over 6. Same thing over here. Ooh, that's a weird looking 2. And x equals 5 pi over 6. Now the last thing in this problem is notice that on this guy over here, we said we wanted just our unit circle values. That's what this restricted domain of 0 to 2 pi is. We don't have that condition on this problem. So when that happens, your final answer needs to be generalized, which is when we add plus or minus 2 pi n at the end of our answers, kind of like we did for coterminal angles. All right, based on what we just went over, you guys should be able to do with some confidence the following problems on the various practice sets. Please make sure you have some of those done before you come to class on Thursday, because we're going to start right off the bat with a practice activity that requires you to have a decent understanding of this foundational solving topic.